Okay, good morning, one and all. So this is the first lecture in module number 5 that we are starting today. Most important module from future study point of view, because this chapter will deal with state variable analysis. Now, many of you would be going to doing digital control system. So those who are going for MS and master studies and all these things, everybody is doing digital control system, statistical control system, because nowadays industries, they are actually run by all those digital control system, statistical control system, etc. And this module actually is the basic of digital control system, because this is called as subspace based method. So if you want to understand digital control system, first thing you have to understand what is called as state variable system modeling. So it is the same writing a few equations of the system. So if I give you RLC system, if I give you first order, second order, so you have seen many kinds of loop wala. So there is one circuit with 2 or 3 loops. There are capacitor, inductor, and there are transient responses and steady state responses, all those things. All those can be formed, all those things can be converted into a matrix form. That means whenever you are writing the current equation, voltage equation, and all those things, we can put all those equations into a matrix form. Why into matrix form? Because we can put into MATLAB, because MATLAB full form is matrix library. It is not for MATLAB the state space is devised, but state space is devised so that computer can do all this modeling, and computer can reduce our work. So all the system modeling, all the system response analysis, transient analysis, steady state analysis, error analysis, and everything about a system, in a system, mechanical, electrical, hydraulic, everything can be done by using a computer. And whenever it is computer or PC, when they want to solve that, they have to solve in the method of matrix. So how can we put any system into matrix form? That we are going to see in this state variable system modeling. So it is called state space modeling or state variable modeling. Sometimes I'm using the abbreviation of SVM. You don't do that in exam because it is not a standard abbreviation. So you say state space modeling, or you say state variable modeling, that will be better. So how to do that? That is something we will. It is very easy. It is not at all difficult. It is very easy. And whenever you are converting the system into state variable model, after that, what? So after that, many different kinds of processing are possible by using computer, which are not generally possible in the differential equation domain. So what are the advantages of state variable modeling? As we keep on going deep into this chapter, we will come to know. System stability analysis, yes, it can be done. There is something called as canonical form. There is something called as similarity transform, which is not there in your syllabus. There is something called as Jordan canonical form. So there are many forms you can convert your system into, and each of the form is having its own advantage. Okay, so if before going for state variable modeling, we should know what are the different modeling techniques we have done so far. So initially we have done impulse invariance modeling, then we have done transfer function based modeling. So transfer function based modeling was having advantage that it is very easy. Directly whenever we are given a continuous time system, first we are converting that thing into differential equation form. So whatever system is given to us, continuous time system, first we are writing its differential equation, and from differential equation, left side is the y, right side is the x. Y is the output, x is the input. From there we are trying to find out what is the ys by xs. So y is the output, x is the input. So Laplace of the output divided by Laplace of the input, we are finding the transfer function of the overall system. And from the transfer function, we have seen we can input different types of input. We can input step, ramp, and we can input impulse, and we can find out what is ys. There is a system response in Laplace domain. From there, take inverse Laplace and find yt. So this was more or less what we have been doing so far. But control system is a research field which is there since last 200-300 years. A lot of mathematicians have put their effort and intelligence into it. So control system never stops. So it is always evolving. So only by finding yt and finding the system response and plotting the graph, we are not happy with that. Something more we want. Okay, so what is that? We want, whenever, suppose one input we are giving and there are 5 different blocks and signals are propagating through every block, and how the signals are changing after every block. If I ask you that, you cannot find out that out by using transfer function modeling. So transfer function modeling, first very big disadvantage is transfer function based modeling cannot give us what happens intermediate. So intermediate in the system. So I'm eating something. So I'm giving an example. My body is a system. I'm eating something and I'm getting energy. So I'm running. So I'm eating something and I'm running. So input and output. But how the food is going into my stomach, how the food is getting digested, how the energy is extracted from there, how the energy is going into every cell, and how is it making me run. So all these intermediate processes, it is not visible in case of transfer function based modeling. Transfer function based modeling biggest disadvantage is it gives me only the relation between output and input. That's all. Intermediate, whatever things are happening, we don't get to know. Okay, because it is ys by xs, but it is not only ys by xs. In signal flow graph, in block reduction, you have seen very big block diagrams are there. Whatever is happening intermediately, we don't come to know. So this is a very big disadvantage of transfer function based modeling, which is solved, or which is that problem is solved in case of state variable modeling. So state variable modeling, after every step, after every component, how the input signal is changing or how the state is changing. So state is something, a definition we have to see what is meant by state. Okay, so we will go slow initially. We will see every meaning of every word and all those things. You can find the state variable analysis. There is a full chapter in M. Gopal. So for all the topics, we are following the book of M. Gopal. Towards the end, there is a chapter, whole chapter called as state space analysis or state variable analysis. All the things I am discussing you can find there. But if you listen, it will be easier for you to understand when you go through the book. Okay, so intermediate system responses we can find out by using state variable analysis. One very important disadvantage of transfer function based system modeling is it can only model when the initial conditions are 0. So there is yt, there is xt. Xt is input, yt is output. So if yt and xt is not having any kind of initial condition, what is meant by initial condition? If you are talking about a capacitor is charging, so capacitor is charging always from 0 volt and it will go to the final, but not necessary that capacitor input initial voltage will be always 0. Not necessary. If the capacitor is holding some around 500 millivolt from the starting, then how the output will be affected by that? Transfer function based method cannot find it out, because that is the biggest disadvantage of transfer function based system modeling. If there is an initial condition, transfer function based system modeling cannot take that into account, but state variable system modeling can take into account that if there is an initial condition, SVM modeling or state space based modeling can take into account that initial condition, and accordingly it can find out what is going to be the final response. So this first, whatever I'm showing you, this is my handwritten note collected from different books. This is actually giving us what is the features and what is the advantages of state variable modeling compared to the transfer function based system modeling. And what is meant by state, that is a very important discussion. So these two things we will see first. And whenever we had been doing the first chapter, transfer function based modeling, we had seen what are their characteristic, what is the advantage of transfer function based modeling, what is the disadvantage of transfer function based modeling. There we had discussed transfer function based modeling is applicable only for linear time invariant system. Okay, linear time invariant system, that is LTI system. But the system is non-linear. If the system is time variant, you cannot apply a transfer function based system modeling. But for non-linear and time variant system, you can apply state variable system modeling. So all the small and big disadvantages of transfer function based system modeling can be overcome by state variable system modeling. And it's a very modern kind of technology. It is using matrices and it is using computer. It is using subspace based method, MATLAB, and all those things, they're supporting it. So always we are going to get a response faster because we are being assisted by the computer. So mainly this is a language, or this type of modeling is a conversion method of all the system into a language which is understood by computer. So differential equation and all that also you can put into state variable model, and you can input that model into computer so that computer can do the processing on your behalf. Okay, what is going to be the step response? What is going to be the ramp response? What is going to be pole zero? How is going to be the transient response? All those things we don't have to calculate. We just have to model it. We have to just process, do the process modeling. We enter the model into matrix form into computer. Then we ask computer, "Okay, chalo bhai, tell me what is the step response." The graph will be given. Tell me what is the ramp response. The graph will be given. So this is the advantage of state variable modeling. So now let us start with all the basics. So I'll be uploading this 16-page document today itself. There are a lot of theories in that, but whatever part I am teaching, you read only that much. So initial 2-3 days, today, tomorrow, or maybe Saturday, we'll be having an extra session of 1 hour, not more than 1 hour. So in this week, we'll be having 3 lectures. In these 3 lectures, I will try to cover all the very basic definitions and theories and all these things. And after that, you start reading this document. And that is my request. And don't read books now, because let me finish the initial part of it. So every topic I tell you that, let me finish the initial part, and after that, any book. So let us now go through this document, which is handwritten, and I will be telling you initially what is transfer function based method and what are their advantage, disadvantage. Some of the things I have explained, so let us just go through. So I've started with a comparison between transfer function based system modeling and state variable system modeling. So both the cases, the same system will be given, and I can ask you that. It will not be asked in the exam, but it is possible that same system is given and I can ask you, okay, chalo, find its transfer function based modeling, and same system I can ask you find its state variable modeling. So there are many types of modeling. Maybe some extra lecture session I can arrange on that when you come in next year, 5th sem and all. What are the different modeling techniques? So database modeling is there. You have heard of data analytics, data science. So the whole system can be modeled from only data point of view. Okay, so it is like that. MBK modeling you have seen, that is mass damper and spring kind of modeling. So that is all entity based modeling. It is called as entity based modeling or differential equation kind of modeling. Okay, but state variable modeling is a different ball game, and transfer function based modeling was one of its kind. So let us find out what is the comparison or what is the discussion. So transfer function, I'm just going through reading from it. Transfer function method of system modeling gives input output relationship of the system, that is ys by xs, all in Laplace domain. This is called external description of the system, because you are only seeing the input, you are seeing the output. So I'm eating the food and I'm running. Okay, how the food is digested, how am I generating the energy, all these things are not understood. You are just seeing me eating it and you are just seeing me running. So you are just seeing what is the input and seeing what is the response. But how the response is generated is not known. State space analysis or state variable analysis gives internal system description, very important thing. So stage wise, how the food is eaten, how it is going into my stomach, how it is getting dismantled, how it is being digested by liver, how energy is produced, how it is going to every cell. So stage wise, internal stage wise, division wise system description is possible by using state variable analysis. So state variable analysis gives internal system description. Transfer function based system analysis give us external system description. So state variable analysis provides insight into system behavior. So I'm just reading from this thing. You are seeing number 1 point, insight into system behavior. What is that? If there is an initial condition, that is taken into account in state variable analysis. State variable analysis allows us to handle system with multiple input and multiple output in a unified way. Very important point. Okay, we found that whenever there were multiple input, multiple output, our transfer function based modeling got stuck. Okay, so that numerical also can be asked. We have to apply superposition principle in that time. One input we have to take into account, other 3 inputs we have to assume to be 0, and then we have to do the response analysis. But state variable system analysis is not like that. It can account for all the inputs, all the outputs together. So that's why state variable system analysis, very important point, is called as robust system representation. So there is a robust control also. So there is a field of study in control system. There are many field of study in control system for vehicle, for drone, for automotive vehicle, underwater vehicle, all those things. You have to do adaptive control system. Okay, so there is a too much of change in the pathway or too much change in the environment. How to control the whole system? So satellite, okay, it is passing through vacuum, it is passing through minus 500, minus 1000 degrees centigrade temperature and all, and every time it can find maybe turbulence while it is passing through the air inside when it is on earth, when it is going into the space. At that time there are different kinds of challenges. Okay, so how to adapt to that? So there is something which is called as adaptive control system. Okay, there is something called as robust control system. There is something called as model predictive control system. So all different types of control system is there. So something is called as robust system representation. So what is robust control? Multi-input, multi-output system. That is called as robust control system. So state variable system gives us a robust system representation and robust control. So robust, the word means is multi-input, multi-output. English meaning of robust is different. English meaning of robust is tagda, ekdam strong. Okay, but whenever I am saying robust control, it means that multi-input, multi-output system, and it is being controlled. So state variable system modeling can support a robust control and robust system description. That means multi-input, multi-output. State variable system analysis can also be extended to non-linear and time varying system. Very important third point. So transfer function based system analysis was only for linear and time invariant system, but state variable system can be extended to non-linear and time varying system. State space system representation is given in matrix form. So that's why we can use MATLAB, and in MATLAB also many commands, many things are there. Very easily you can find out very important system features by using MATLAB and state variable to check. Okay, so what is meant by state? First you have to understand what is meant by state. So ये सब exam में आने वाले question नहीं है, but actually I am introducing you with a very important concept. That's what I am taking little time initially, because I am building it up for this system. So what is meant by state? What is my state as a human being? So as a human being, there are 20 vitals, vital signs. Whenever you go to meet a doctor, तुम्हारे अनजाने में doctor checks all these 20 vital signs. Okay, some of the vital signs he tells you and check, like your heartbeat, like your pulse rate, your pressure. Okay, आँख ऐसा करके देखता है आँख के नीचे लाल है कि नहीं. He asks you to put your tongue out and checks what is the tongue color of your tongue. He asks you to show your palm like this, palm का color देखता है. Okay, so he comes to know about whether your heart is functioning properly, whether there is enough hemoglobin or blood in your body, whether your body temperature is in the range, okay, whether you are breathing properly. All these are vital signs. How you are walking, in your walk, whether you are walking energetically or how you are sitting. Okay, डॉक्टर के पास जाओगे तो डॉक्टर तुमको देखेगा. Some BP patient goes to doctor and डॉक्टर उसको बोलता है तुम 5 मिनट बैठो, because he checks the state. What are the states? 20 states है. वो जो 20 vital signs है, you can check Wikipedia. What are the 20 vital signs of your human body? Whenever a student come to us, okay, we check. कुछ student को हम बोलता है भाई तू बहुत jittery hai, always you are jittering, calm down, okay, calm yourself, concentrate, because some students are very good but they are having a focus issue. So okay, so those are our vital signs. We are academicians, but whenever you are going to a doctor, so those are the things, those are the points which are called state of human body. So what are the state of your body? So there are 20 states. So it's a bunch, it's a array of 20 parameters. So you just find out in Wikipedia, you will be finding that it's an array of 20 parameters which are called as vital signs. What are the vital signs? Tongue ka color, aankh ka color, your body temperature, whether you are sweating or not. Okay, what is your heart rate, what is your breathing rate, and all those things. Okay, toe ka color, palm ka color, all those things. Nails, okay, nail color, all those things are there. So this is actually what is meant by state. If I'm talking about, now I'm coming to a system. If I'm coming talking about RLC circuit, okay, it's a series RLC circuit. This is, and very important, there is a relationship that order of the system. So now I'm telling you a very important thing. Order of the system is equal to number of state available in the system. Okay, so what is the order of a RLC circuit? RLC circuit is a second order system. Why so? Because there are two energy storing element. Who are the energy storing element in RLC circuit? One inductor and one capacitor. Resistor does not store energy. Okay, so resistor is a opposition offered to the flow of the electron, but resistor does not store energy. Who stores energy in RLC circuit? One capacitor and one inductor. So there are two there are two energy storing element in the RLC circuit. That's why we find in its transfer function, the characteristic equation is S square. That means characteristic equation is having order 2. That means for a second order system, to define a second order system, you need two state variables. So this is a very important understanding. If it's a third order system, that means there are three energy storing element. So the same circuit, if I give you a circuit with two inductor and two capacitor, so the order of the system will be 4, because there are two inductor and there are two capacitor. That means there are 4 energy storing element. As there are 4 energy storing element, the order of the system will be 4. In the transfer function denominator, you will be finding s raised to 4 term will be there. So as there are 4 energy storing element, order of the system is 4. In that case, if you want to represent that system by using state variable method, you will have to define 4 states. So second order system, we have 2 states. Okay, so which are the states? This is the biggest thing in the state variable analysis. State can be anything. Anybody can take any state. So I give you a RLC circuit and I ask you that do the state variable representation of the system. Now, there is no standard modeling technique. Every student can find different state variable representation for the same system. Okay, so this is the biggest fun of this. It depends on which is the system parameter you are defining as a state. But generally saying, there are 2 states. Which are the 2 states? So it's a RLC series circuit. So current flowing through the circuit, IL, okay, or I, current flowing through the RLC circuit, that is one state. Okay, so as instantaneously the input is changing, the current flowing through the circuit will change. So this I can be taken as one state. Another thing can be taken as a state is capacitor voltage. So I generally we called as IL or IR or IC RLC series circuit. Okay, so generally we call it IL. Okay, IL is same as IR, IT, IN, because it's a series circuit. All the components are carrying the same current, but we call it inductive current generally, because generally we find that whenever frequency is very high, XL is very high, so circuit will behave like an inductor. So that's why I we call as IL. So IL can be one state of RLC series circuit. What can be another state? VC. Okay, capacitive voltage can be another state of RLC circuit. Now somebody will say, or just for argument's sake, sir, why should I take only capacitive voltage as a state? I can take VR, that is resistive voltage, as a state. You can take. It is not wrong. Somebody will say, why I have to take I as a state? I will take VL and VC as the 2 states. You can. That is right. Okay, only thing we have to see that whichever parameter are changing with time. So if you are saying that VT is the instantaneous input voltage, IT is the circuit current. So whenever there is a change in VT, IT will change. Whenever there is a change in VT with respect to time, VCT will change. VCT stands for capacitive voltage. Whenever there is a change in input voltage with respect to time, VRT will change, resistive voltage will change. So actually you are finding there are 4 parameters: resistive voltage, inductive voltage, capacitive voltage, and current. Out of these 4 parameters, any 2 parameter you can take and you can say that these are the 2 states of the system. ये 4 छोड़ के और कुछ नहीं होता है. Okay, so for RLC series circuit, if you see, maximum there can be 3 voltages and maximum there can be 1 current. Okay, so that current is actually IL or IR or IT or IN, कुछ भी बोलो उसको, input current, resistive current, inductive, capacitive, and that current can have an initial value also. Okay, because state variable analysis can take into account of any initial current or initial value of voltage or initial value of current. So there can be maximum 4 state in, or maximum 4 parameters in this case, VR, VL, VC, and I. Okay, so any of these two parameters you can take, and you can represent the RLC series circuit perfectly. Which two you want to take? It's up to you. I'm not going to tell. And but two you have to take maximum. Somebody says, sir, can I take three? Can I take three? Yes, you can take three. But the point is, if it's a second order system, you cannot change the order of the system. If it's a second order system, to completely define its functioning, or to completely define it by state variable analysis, maximum two state if you take, that is enough. Maximum two variables you take, and you can tell about their states. Okay, so these two parameters are called state variables. IL is a state variable, VL is a state variable, VR and VC, they are called as state variable. And what is meant by state? At every time instant, the amplitude of IL is changing. So if I tell you what is the value of IL at t is equal to 0, you can find out IL is equal to an equation. Let's say 2 into e raised to minus 3t. This is the equation of IL. Okay, so this is the equation of the state variable. Now substitute t is equal to 0. You can tell me what is the value of IL at t is equal to 0. I ask you, tell me what is the current at t is equal to 5 seconds. So substitute t is equal to 5. You can tell me what is IL is equal to t is equal to 5 seconds. So there is state variable and there is state. So there can be maximum two state variable to define a second order RLC circuit, because order of the system is 2. Maximum state variable you require to completely define the system. This is a very important word, completely define the system. Maximum state variable you require is 2. So generally we take for RLC system IL as one state variable and VC as another state variable. But somebody wants, they can take different state as well. VR and VL you can take, VC and IL you can take, VL and IL you can take, VR and IL you can take. So we will solve this RLC numerical with different combination of state variables, but maximum two state variables we will take. So maybe next day, and we will see that the state variable representation actually changing if we are taking the different state variables. So what is meant by state? If you are taking IL equation IL of t and VC, you are having an equation of IL, you are having an equation of VC, and there you keep on substituting t as different value, and you are getting different values of ILT, you are getting different values of VCT. That means inductive voltage and capacitive voltage at different time instance. So that is called as state. ILT at t is equal to 0, yes, you can calculate. ILT at t is equal to 1, you can calculate. ILT at t is equal to 2, you can calculate. Just keep on substituting the value of t as 0, 1, 2, 3. So you are finding different value of state variable at different state. So that is what is called as state. Abhi, now what is my heart rate? My heart rate is now 72. Okay, मैं थोड़ा दौड़ के आया after 5 minutes. How much is my heart rate? My heart rate has increased to 90. So now at time t is equal to 0, my heart rate is 72. After maybe 5 minutes, my heart rate becomes 96. So that is the state after 5 minutes. After 10 minutes, again so after 5 minutes दौड़ के आया, and then I kept quiet, चुपचाप बैठा रहा. Again my heart rate comes back to 72. So at t is equal to 0, my heart rate is 72. So that is the state. What is the state variable? Heart rate. What is the state? 72 bit per minute. After 5 minutes, what is my heart rate? 90 bit per minute. So that is the state after 5 minutes. Then I'm taking rest from 5 minutes to 10 minutes. My heart comes back to the normal beating again. After 10 minutes, how much is my heart rate? So what is the state? Again, 72 bit per minute. So likewise. So this is a difference of state and state variable that you have to understand. So state variable is nothing but the IT or VCT that you are defining depending on the system parameter. So for defining state variable model, you should be knowing the system states very well. So तुमको different systems के बारे में पता चलना चाहिए. If you cannot understand a rocket, if you don't understand a satellite, how it moves and all those things, you cannot define state variable. So that's why am I telling you that always keep on reading from different sources and understand different system modeling technique. Suppose I tell you it's a car, it's going at this much speed and all these things. Tell me what is the state variable model. But if you don't know what is the velocity equation, what is the acceleration equation, what is the brake equation of a vehicle, then you cannot write what is the state variable model of the vehicle. Okay, so if I tell you, tell me what is the state variable model of Indian economy, okay, national income or national loss, what is the state variable model of COVID? Possible. Okay, so for that you should know all the parameters which is affecting COVID. You should know for national income or Indian economy. You can put it in a state variable model. So in that case, number of variables will be more. Order of the system is more. Maybe there are 100 main factors which are defining the Indian economy. 100 main factors. So it's a 100 ordered system. So in that case, the transfer function will start at s raised to 100 plus something of s raised to 99 plus something of s raised to 98. Likewise, it will go to s raised to 0. Okay, so this is a brief explanation about state and state variable. So for second order RLC system, there are two energy storing element. That means this is a second order system. That means to define the system completely, maximum two state variables you have to define. Which state variable you define? Out of 4, you can take any 2, and this system can be perfectly defined. Now let us see what is the formal introduction. What is the definition of state? It is the minimal information. Very important point. Minimal information that is sufficient to determine the response or output of the system for all time t greater than equal to t0. Okay, so initial time is 0. And after that, at any instant, so at t is equal to 0.1, 0.2, 0.3, 0.4, if you are taking the time intervals very small, in that case, number of state will be more. So if I tell you that IT or IL is equal to e raised to minus 3t, just give an example. The current flowing through the RLC circuit, that is ILT, is equal to e raised to minus 3t, because it's a decreasing kind of a current, e raised to minus 3t. Now I ask you, tell me the current after every 0.1 second. So how many states will be there between 0 to 1? There will be 10 states or 11 states. You have to find current at 0th second, 0.1 second, 0.2 second, 0.3 second, 0.4 second, and you have to tell me that, sir, from 0 to 1 second, there are 11 readings. Okay, so that means there are 11 states in between 0 to 1 second. But if I ask you, tell me what are the currents after every 0.5 second. Okay, so in that case, you have to give me only 3 reading: 0th second, 0.5 second, and 1 second. Okay, so states is in our hand. How much is going to be the sampling instant? How much is the time precision we require? How many states we want to generate between any interval? That is there in our hand. Okay, so it is a state. What is the definition of state? It is the minimal information that is sufficient to determine the response or output of the system for all time t greater than equal to 0, when input to the system is also known for all time. Very important thing. So you should know what is the input to RLC circuit, VT. It's a step input. So you are knowing the input for all time t greater than 0. That means starting from 0 to t is equal to infinity, for all time, you know how much is the input given to the system. In that case, you can determine what is the ILT and what is the VCT at any time instant. That is a very big claim. At any time instant, you can find out how much is going to be the current and voltage in any component in the system with initial condition. Even if the capacitor was having some initially stored voltage, yes, taking into account that initial voltage, you can tell me what is the present voltage in the capacitor after 0.5 second. Even if there was an initial current present in the inductor, taking that into account, you can tell me by state variable method and how much is the inductive current after 0.7 seconds. So any time you can tell me how much is going to be the ILT and VCT, provided input at any time is known to you. So very important definition of state. It is a minimal information that is sufficient to determine the response or output of the system for all time t greater than t0, when input to the system is also known for all time t greater than t0. So this is called a state. How much is the value of IT at t is equal to 0.1? How much is the value of IL at t is equal to 0.2? So these are states of inductive current IL. What is meant by state variable? Variables that contain this information are called a state variable. So for RLC circuit, you have to remember IL is a state variable. VC, capacitive voltage, is a state variable. VL, inductive voltage, is a state variable. IR, that is the resistive current is a state variable, which is same as IL. VR, resistive voltage, is a state variable. Okay, and what are their values at any time instant is called as state. So what is state and what is state variable? These two things we are defining so far. So now this applies only for causal system, and state of the system is related to memory of the network. So what is meant by memory of the network? Memory is directly related to the order of the system, and whatever state variable we are doing. So far one constant we have found that it is used for causal system. So it is related to the memory of the network. For continuous time system, generally what we are finding is the number of state is equal to the number of energy storing or memory element. So if I am saying it's a RLC system means there are two memory elements. That means there are two energy storing element, L and C. So for RLC system, there will be maximum state variable 2. Okay, so there are 4 variables. You can take any 2 and you can define the whole system and its responses by means of 2 state variable. So for continuous time system, they are integrators, adder, amplifier. So these are different state components. Okay, so choice of state variable for a system is not unique. Very important point. The choice of state variable for any system is not unique. So 2 persons doing state variable model for the same system of the same order, maybe it's a third order system, but they have chosen different state variables. So for both of them, the model of the system will be different. Okay, so as long as everybody is doing it correctly, everybody is having the correct answer. Okay, so there is nothing called as a unique answer for state variable. It is not there. Okay, so depending on what state variable you are choosing, you are going to get the system model accordingly. So there can be many state variable matrix representation for a single system depending upon the states or variables defined by the user. So write the state equation for the electrical system shown below. It's a big numerical. We are not going to do it now. Let us go to a very simple numerical.